Welcome to day 35 weekly assessment for the STL Mastery series. Today we are taking a step back to assess your progress and solidify your understanding of the essential STL tools we have covered in week 5. This assessment will test your grasp on paired, tuple, bit set, optional, variant and more. You will tackle multiple choice questions, code tracing challenges and coding exercises to ensure you are ready for the final weeks ahead. Today's goals are simple but essential. We will evaluate your theoretical understanding of STL tools, ensuring you are comfortable with key concepts. You will put your practical coding skills to the test through coding challenges and problem solving exercises. You will identify areas that need extra attention before we move into the final stages of the course. This is your opportunity to assess your strengths and pinpoint areas for further improvements. So let's dive into the assessment. Here's how we will structure today's assessment. Part A. The first part consists of 10 multiple choice questions that will test your understanding of STL concepts. Each question focuses on specific topics like bit sets, optional types, map, operations, and more. Part B. Next, we will have 5 code tracing problems. This will ask you to analyze a piece of STL code and predict its behavior. It's your chance to demonstrate how well you understand STL containers and algorithms in action. Part C. In 3 coding challenges, you will apply your skills to real world problems, solving them using STL tools like pair, tuple, map, and others. Part D. Finally, there's an optional mini project for extra credit. If you want to earn bonus points, this project will allow you to showcase your creativity and problem solving skills with STL in a more complex scenario. Here are a few sample questions from part A to give you a sense of what to expect. What happens when you apply the XOR operator to two bit sets of the same size? How does optional differ from variant and when would you use one over the other? If you wanted to store different types of data, how would you use tuple to make your data structures more efficient? These questions will test your ability to recall theoretical concepts and distinguish between related STL tools, so be sure to pay close attention to the details. Now let's move on to part B, which consists of code tracing problems. For example, you may be given a code snippet where you are asked to trace the output of a program that uses a vector of pairs and sorts it based on a custom comparator. This is an important skill. Being able to predict the behavior of STL algorithms and containers in real time will make you a more efficient programmer. The goal here is to evaluate how well you understand the flow of STL operations. In coding problem 1, you will write a function called filter event that processes a vector of integers. The function should return a vector of optional int where even numbers are wrapped in optional int and odd numbers are represented as null OPT. This problem tests your understanding of optional and conditional handling. It's a great opportunity to solidify how optional values work and how you can conditionally wrap or skip certain values based on their content. Next, we have coding problem 2, which is all about grouping data. You will need to organize a set of student records containing roll number, name, and grade into a map based on their grades. The map will use char keys for the grade and store a vector of tuples for each student in that grade. This challenge tests your ability to manipulate map, tuple, and vector and how to efficiently group and store data in STL containers. For coding problem 3, you will work with a bit set to simulate a basic 8-bit register. You will need to implement operations like set, reset, flip, and display the state of the register. This problem is a fantastic way to apply your understanding of bit set and bitwise operations. Working with bit sets is an efficient way to manage binary data, and this challenge will give you hands-on practice with manipulating bits at the lowest level. For the optional mini project, you will build an arithmetic evaluator using std::: function or functors. The evaluator should take an operator and two operands, then compute the result based on the operation. You can use a map char, function to map each arithmetic operation to its corresponding function. This project is designed to push your limits by applying advanced STL features like function, map, and lambda expressions. If you complete this project, you will earn extra points and more importantly gain deeper insight into how powerful STL can be. Let's take a look at the scoring guide. In part A, MCQ is worth 20 points with 2 points per questions. In part B, coding tracing is worth 20 points with 4 points per problem. In part C, the coding problems are worth 45 points with 15 points per challenge. Part D is worth an additional 15 points for extra credit. Altogether, you can earn up to 100 points in this assessment. After you have completed the assessment, take some time to reflect. Which problems did you find easier or more challenging? Are there any areas where you struggled? This is a great opportunity to review any topics that you are not completely comfortable with before moving on. Remember, it's okay to revisit concepts that may need more practice. The more you understand STL, the better prepared you will be for the final project and beyond. Looking ahead, we are about to enter week 6. We will begin applying everything you have learned in real world scenarios. We will work on our final project, participate in mock interviews, and prepare for our certification exam. This week is all about practical applications of STL in industry standard projects. Keep up the great work and let's finish strong in the final stages of the course.